Let's take a look at the first example. We have cube root of x minus 2 minus 4. Before I'm going to do anything with the cube root, I'm going to remove negative 4 to the other side. I have to make sure that I'm going to have only cube root on left side. So I have cube root x minus 2 is equal 4. In order to eliminate cube root, I have to raise left side to the third power. If I'm going to raise to the third power, this exponent is going to eliminate my radical sign. Whatever I did on the left side, I have to do also on the right side. I have x minus 2 is equal 4 to the third power is equal 64. In order to find x, I have to move 2 to the right side. X is equal 64 plus 2. X equal 66. Let's check if this is correct answer to my problem. I have cube root and I have to replace this x by 66. I have 66 minus 2 minus 4 has to be equal 0. I have cube root 66 minus 2 is 64. Minus 4 has to be equal 0. Cube root 64 I can rewrite as 4 to the third power minus 4 has to be equal 0. Cube root and third power is going to cancel out. I have 4 minus 4 is equal 0. 0 is equal 0. Left side is equal to the right side. That's why x equals 66 is the solution to my problem. Let's take a look at the second example. Anytime you have a problem like this, you're supposed to start always from the most complex radical. Okay, so I'm going to start from this radical. I'm going to eliminate the radical sign by squaring this radical. So radical sign is going to be cancelled by this exponent, and whatever I did on the left side, I have to do also to the right side. I have 12 plus a equals. Please notice that this is nothing else, just the square of the sum. Do you remember the rule for the square of the sum? X plus y to the second power is equal x squared plus 2x y plus y squared. I'm going to apply this rule to my right side. This is my x and this is my y. The formula says x has to be squared. I have square root of a to the second power plus 2x times y. This is my x square root of a times y, which is 2, plus y to the second power, 2 to the second power. Let me copy this down. 12 plus a equals square root of a is equal a plus 2 times 2 is equal 4 square root of a plus 4. Next, I have to bring all terms which have a to one side of the equation, and everything without a is going to be moved to the left side of the equation. Now, because I have more a's on the right side and all of them are positive, I'm going to take this a and I'm going to move to the right side. Now, because this 4 has no a, I'm going to take it, and I'm going to move to the left side. I have 12 minus 4 equals a minus a plus 4 square root of a. 12 minus 4 is equal 8. Equals a minus a is 0, and I have 4 square root of a. I have to find a. First, I have to make sure that I'm going to remove 4 from my radical sign. Because I have multiplication, I'm going to divide both sides equation by 4, by whatever is multiplied to my radical sign. 4 and 4 will cancel out. 8 divided by 4 is equal to, equals square root of a. In order to find a, I have to remove the radical sign by squaring that radical. Whatever I did on the right side of my equal sign, I have to do also on the left side. This square is going to cancel this radical sign. And I can say a is equal 4. Let's take a look if this is proper answer to my problem. I'm going to replace every a in my equation by 4. And I have square root of 12 plus 4 equals square root of 4 plus 2. Square root of 12 plus 4 is equal 16. Equals square root of 4 is 2 plus 2. Square root of 16 is equal 4. 4 is equal 4. As you can see, left side is equal to the right side. That's why a equals 4 is the solution to my problem.